Hello everybody and welcome to section 20.3, the curl of a vector field. Well, actually this is the second video for this topic, and I hope you watched the first video where I demonstrated the idea behind the circulation of a vector field using a little model of a pedal wheel. So in this video we are going to look at the same example, one of the two examples that we saw in the previous video, in more of a theoretical point of view, and write down some things. And so we are going to look at that example again and define what we mean by the conceptual description of circulation. Okay, so here's the situation. We have F, our vector field, and imagine we have our pedal wheel that is drawn right here, and you can see it has a handle. Right here is our handle, and then it has the pedals over there, and we are placing this little tiny pedal wheel inside of a vector field so that the bottom part right here is located at one point in our vector field, at the point XYZ, and the handle points in some direction. And so it points in the direction of the axis that we want to measure the circulation of F around. So as I was demonstrating in the previous video, when we have a vector field and we're placing our pedal wheel in there, the handle can point in many different directions, and depending on how it's located, there might be rotation going on or not. And so we need to consider not just the point where we are placing the tip of the pedal wheel, we also need to consider in what direction the handle is pointing. And so we say that the velocity, the angular velocity of our pedal wheel, once we made those choices, measures the strength of the circulation. So the angular velocity of the pedal wheel, so how fast it's twirling, it's rotating, measures the strength of the circulation. And again, you saw when I demonstrated this, that even if I put the pedal wheel at the same point, if it's, with one example, the handle was pointing upward and the wheel was rotating counterclockwise, and then I turned it around and it appeared that the wheel was rotating clockwise, we associate a sign to these different directions of rotation. So we say that the circulation is positive if the rotation is counterclockwise, and negative if the rotation is clockwise. And the way that we are gauging this is we are looking down the handle of the pedal wheel. So imagine your eye is right there at the top of the pedal wheel, and you're looking down, and then you see, is it rotating this way? That would be counterclockwise, or is it rotating this way? So that would be clockwise. All right. Let's look at the example that we already saw in the previous video. The preliminary example right here, looking at the vector field on the right. This is the same vector field that I was attempting to draw on my little whiteboard. So there is rotation going on in every plane that's parallel to the XY plane. So we have this rotation going around this way, no matter where we are in our vector field, 3D vector field, there's this type of rotation going on. Okay, let me clear this up. All right, so now we have this vector field F right here, and we are placing the pedal wheel in at the point 0, 0, 0, and we would like to decide whether the circulation of the vector field at 0, 0 around three different axes is positive, negative, or 0. So the point 0, 0, 0 is right in the center of this box, of this vector field. And so at first in part A, we place the handle in so that it's pointing in the same direction as the vector k. So K is the Z direction. So we are placing in our pedal wheel so that the bottom is right here at 0, 0, 0, and the handle is pointing up. And so the blades would be down here. So I'm attempting to draw in my blades. This is the vector K. So this is my pedal wheel. And up here is my eye. I'm looking down this axis. My eye is up here. And so which way is this rotating? So you can see my pedals are going to be pushed in this direction. And if my eye is up here at the top of the handle, that would appear to be counterclockwise. So this is counterclockwise rotation. And so my circulation is positive. So circulation is positive. Okay. Try to convince yourself that that is the case. So for part B, we are looking at the handle pointing in the direction of minus K. So let me clear my picture. So I put in again the bottom of the pedal wheel, or goes at the point 0, 0, 0. But now minus K is going straight down. And so the pedals are up here. My eye is down here. And what is the rotation? It's around this way. So at first glance, it looks like it's the same direction, but now your eye is down here. And so as you're looking up into the vector field, you will see that the rotation appears clockwise. We have clockwise rotation. So if our handle points in the direction of minus K, we have that the circulation is negative. And then for the third example, we are putting in the handle in the direction of J. Okay, let me clear my vector field, my drawing. So now we still have the bottom of the pedal wheel is at 0, 0, 0. Y, the y-axis right here is my y-axis. So we are pointing in the positive y direction with vector J. This is J. So my eye is over here on the right. The pedals are sticking straight up and down, and the rotation is still going around like in the plane parallel to the XY plane. And so you can see that there is not going to be any pushing of those pedals. So the circulation is 0. Okay, so you can see, even though we're looking at the same vector field and we are placing the pedals at the same point, depending on what direction the handle is pointing, so depending what axis, about which axis we want to measure the circulation, we get 3 different answers.